As we have studied many new terms in previous classes. So linear motion and angular motion. If you have noticed it, so you can see that. So linear motion, it is distance. Linear distance is s. And what is the angular distance, everybody? Angular distance will represent with what? Theta.
Theta.
So linear velocity with v and angular velocity will represent with what? Everybody? Omega. Am I right or wrong? Yes or no, everybody?
Yes.
And we have been found the relation that what is the angular linear displacement and angular displacement relation. Linear displacement is equals to radius into angular displacement. Am I right or wrong? Same way, linear velocity is equals to radius into, everybody respond, angular velocity. Right or wrong?
Velocity.
All of you. Yes. So now if you have
Yes,
noticed,
sir.
basically we all people knows that. So velocity is equals to displacement by time, that is what ds by dt. So if I apply the integration, if I want to apply, for example, so I will get it what? Integration of ds is equals to what will happen? Integration of v dt. So integration of ds is s. So s is equals to what is the formula, everybody? S is equals to what is the formula? Displacement is equals to, linear displacement is equals to integration of v dt. Right or not?
VDT.
All of you? Same way. What is the angular velocity? So angular velocity formula. So what is the angular velocity formula, everybody? D theta divided by dt. So now if I apply the integration, so it will come omega dt is equals to d theta. So if I apply the integration both the direction, integration of d theta, which is equals to what? Theta. So theta is equals to what is the formula, everybody? Omega d theta. So this is what we have studied till last class. So all of you remember. I don't know why these people are not able to join. Just a minute. So anything I logged the meeting? I don't think so, correct? Everything is okay. I don't know. It's okay. So now observe very carefully. So this is what we have studied. And yesterday at the last numerical we have studied. If you want to find number of revolutions in a given period of time. So what is the formula? Number of revolutions is equals to, all of you, please respond. Theta divided by 2 pi. So this is what for calculating number of revolutions in a given motion. So this is what we studied till yesterday's class. So all of you remember once again, angular displacement is theta, linear displacement is s, linear velocity is v, and angular velocity is omega. Relationship between linear displacement and linear angular displacement is s is equals to r theta. So r means what, everybody? What do you mean by r? Radius. Clear, everyone? So now today's class we are going to study remaining terminologies. You can see yesterday heading. What is the yesterday heading we have kept, Mr. Rudreswar? We have kept the heading that introduction of terminologies. What is the S, theta, V, omega, and next one AT. What do you mean by AT? Anybody? Tangential acceleration, AC, centripetal acceleration, next alpha, angular acceleration, net acceleration.
AN.
These all the things. AN means net acceleration. These all the things we have been kept it. So now let us discuss what is this all the things. So now let me consider if any kind of object. See, I will try to draw the shapes also very perfectly. So please see how to draw. So imagine there is a circular path. So every time I will draw, you can make it. So I will draw. It is like imagine it's a circular path. Circular path illa. Object is revolving in a circular track. Just for our purpose, I am drawing. Okay. So now imagine, so there is a fixed point which we used to call as a pivot point. So from that towards to the surface, we used to call something. What is that called as, everybody? Yes, please. We used to call as what? Radius. Am I right or wrong?
Radius.
Imagine there is a scale which has been attached to the pivot point. What do you mean by pivot point, everybody? Fixed point. Everybody. So now this body started revolving in that. So let me choose a 2 points now. So you can take it, this point and or else this point. So what is the velocity, tangential velocity of this body? So if I draw a tangent there, that is what the velocity. For this particle, if I draw here a tangent, that is what the velocity, tangential velocity. Am I right or wrong, everybody? Clear? So if I take this body, this point at any point, so always the direction of velocity is always tangent at the particular point. Am I right or wrong, everybody? Clear? All of you?
Yes, sir.
So if you have take it
Yes, sir.
ninth class you have studied, I already told you many times. So 9th class, you studied the circular motion. Of course, rotational motion, or we can say rotational motion only. What motion we can say? We can call it as circular motion. So
Circular.
Okay. So now 9th class, you studied two things. So we can see that at every point, velocity remains constant or changes everybody. All of you in a circular path. For any point on rotating body, V remains constant or is it varies? Everybody, speed not
Varies.
velocity. Yes, please
Varies.
respond.
Varies.
So I already taught you in 11th class also the velocity of a body. So magnitude of velocity we used to call something. Anybody? Magnitude of velocity we used to call as what? Speed. So we can changes by two ways. One is by what? Anybody can tell me? We can
magnitude
change
direction.
by one is direction changes. So if you have noticed it, direction changes means in the sense of what? At every point, the magnitude of velocities remains constant. This is what used to called as uniform circular motion. Am I right or wrong, everybody? Class 9th, you might be studied that. Uniform circular motion means magnitude of velocity remains what? Everybody. Magnitude of velocities remains constant. That is what you have been found formula. Speed is equals to circumference of a circle divided by time. This is what you have done in 9th class circular motion. Am I right, everybody? Clear? Yes, all of you. But now you can see, so here, this velocity, see this velocity, this velocity, this velocity, everything maybe remains constant. So the velocity is not constant. Who is remains constant, everyone? Magnitude of velocity remains constant. Who is that? Everyone. Magnitude of velocity remains constant, but here something is keep on changes. What is keep on changing? Everybody. Direction. So keep it in mind, when magnitude of velocities remains constant, but velocity changes because of what? Pradosh, can you hear me? Velocity changes because of what? Velocity changes because of direction. Then at this time, we'll be having a centripetal acceleration. What acceleration we have, everybody? Centripetal acceleration. So centripetal acceleration formula is, all of you observe. So if I take the centripetal acceleration, so from the center, let me take any kind of object, so which has been attached. So the radius is this one. So at any point, you can take this point or whatever the point. So velocity is V and the radius is R. Let me take, this is the point. So what is the centripetal acceleration? All of you? Centripetal acceleration AC is equals to V square by R. This is the formula for calculating the centripetal acceleration. Now, V can be changes by direction. Of course, V also can be changes by what? Anyone? V also can be changes by what? Magnitude. Means at here, let us imagine maybe velocity is 5 meters per second. Example I'm taking. Here maybe 10. Here maybe again 5. Here maybe again 15. So we don't know. Like that magnitude of velocity keep on changes. Then that is also velocity changes. Am I right or wrong? Both magnitude as well as direction changes. So velocity changes by magnitude. Remember, magnitude changes by the time the body which is in circular motion is having AT. So AT means what? Tangential acceleration. So tangential acceleration means differentiation of magnitude of velocity divided by dt. Do you understand, Pradosh? This is what we used to call as tangential acceleration. What we used to call, everybody? Tangential acceleration. Now, so what is this direction of tangential acceleration? So tangential acceleration remains constant or varies everybody at every point. Velocity is varies by magnitude. So magnitude is varying. So that what will happen? Tangential acceleration also, it will be varies. Do you understanding, all of you? But centripetal acceleration. So let us imagine that this body which is revolving in a circular track. So I will take a circular path, just imagine. So just 3 different positions I will imagine that. See, for your purpose only this much I am drawing. So you have to be utilized very properly. So imagine here the body and here the body and some other position. So let me take and we'll draw. So imagine from attached point, pivot point. What is that point we used to call as? Fixed point we used to call as what? Pivot point. So from the pivot point, so there is, imagine that there is a body now. So whose length is L, that is what radius is R. And let me take this point is P. What is this point, everybody? P, you just imagine. So can you tell me what is the direction of centripetal acceleration? Centripetal acceleration, all of you. This is the direction of centripetal acceleration. Am I right or wrong? Everybody please respond, guys. What are the point I take?
Yes,
Clear?
sir.
Mr. Rudresha? Now, what is the direction of velocity here? I draw what? I have to draw. If I want to find the direction of velocity at this particular point, what I have to do? Everybody, respond. I have to draw the
Tangent.
what? Tangent.
Tangent.
That is what? Tangential velocity. Now, at this point, you remember, maybe magnitude of velocity. Magnitude of velocity, that is what? Maybe increases. So increases means then tangential acceleration also upward or downwards? Everybody. Upward direction. Do you understand, everybody?
Upward.
If magnitude of velocity increases, then acceleration, tangential acceleration is upward direction. If magnitude of velocity decreases, then tangential direction is what? Anti. Anti means it will come act as a what direction? Everybody, please respond. Downward direction. Do you all understand, everybody? If velocity at a particular point, if the tangential velocity increases, then tangential acceleration is also positive. And as a positive not, both are same sign. So both are same direction. So that what will happen, guys? Tangential acceleration is also upward direction. If velocity at that particular point is decreases, then tangential acceleration will act what direction? Everybody. Yes, please. Downward
direction.
Understanding? So magnitude of velocity increases, then AT is same direction or opposite direction? Everybody, please respond.
Same direction.
Same direction. If magnitude of velocity decreases, then what direction, everyone? It will be in
Opposite.
opposite direction.
Opposite.
Keep in mind, always AT is parallel to VT. When both velocities increases, then same direction, tangential acceleration. Or else AT is anti-parallel to VT. When, guys? When it is anti-parallel to VT? When VT is decreasing or increasing?
Decreasing. Decreasing.
So that AT will act same direction or opposite direction? Everybody. Act opposite direction. I hope everybody understand. Mr. Rudresh, were clear? All of you? That is what. Now imagine
Yes,
this same body. Now the same body has been rotated and it has been came to here. At this position. Your choice, you can take it. Now, or this body has been made into this position. So everywhere you can see the particle is same. Am I right, brothers? The same particle. So here, what is the acceleration, centripetal acceleration direction? Towards to the center. Here also centripetal acceleration. What is the direction, everybody? Towards to the center. So, all of you remember, the centripetal acceleration always acting towards the center. So whatever the particle inside the system, any internal particle of the system, centripetal acceleration remains constant or varies? Everybody. Centripetal acceleration remains constant, but tangential acceleration is not constant. So tangential acceleration may be same direction to the tangential velocity or opposite direction to the tangential velocity. If V increases, tangential acceleration is same direction as tangential velocity. V decreases, opposite direction. Is it okay, everybody? Please respond, guys. Girls?
Yes, sir. Yes, sir.
That is what. Now if you observe, so as this is acting along the radius, so centripetal acceleration also I can represent with what? Anybody can tell me? Which is acting along the radius. So I can write it as a radial acceleration, Mr. Rudreswa? Yes,
sir.
That is what. So centripetal acceleration also we can kind of what? Everybody, radial acceleration. Or else, one more thing let me take. Once again, I will draw. So let me draw one more circle. There is another name for this tangential acceleration, centripetal acceleration. So which is, if you observe very carefully, so that you'll understand. Mani, call to that Aswita, not interested means leave it. Today is the last day. I don't want to make any call from today onwards. Whomever it is. Nonsense people every day. Why we should worry? Leave it. That's not bad. So now if you have noticed it here, all of you, just imagine. So I will consider a particular particle. So just imagine this is what is my particle. Let me take another color so that you all understanding. So please, any doubt, please kindly ask me, everybody. So we all knows that at this particular point, centripetal acceleration always act towards the what? Everybody. Yes, please.
Center.
Towards to the center. And at the particular point, if I draw a tangent, then what acceleration I will get it? Everybody.
Tangential
acceleration.
So what is the angle between them always? We all people knows that. What is the angle between them? 90 degrees. So if I imagine this is what is the perpendicular line, so it is acting how, brothers? This is also we can call normal. Suppose if we draw like this is called as what? We used to call it as what? Normal. Do you understanding all of you? That is why the acceleration which is acting along the normal perpendicular, understanding? So perpendicularly to this tangential acceleration. So that is why centripetal acceleration or radial acceleration also we can call it as normal acceleration. What is to call, everybody? Centripetal acceleration, radial acceleration, or we can say normal acceleration. Is it clear, brothers? Understanding? Now, so we all people knows that. All of you observe, if the centripetal acceleration is acting like this direction and tangential acceleration is acting like this direction, and the angle between them is 90. So now you tell me, net acceleration will act where? Anybody? We are very familiar with this. Net acceleration, which will act in between them. Am I right or wrong? Everybody? Please respond. So that is what A net. So net acceleration is equals to, this is what? So A net. So if I imagine parallel shift method, if I imagine this parallel shift, you can see, so it will form a triangle. So we'll get A net is equals to, all of you remember, Pythagoras theorem if I apply. So what will happen? Everybody. Centripetal acceleration, square of
T square plus AC square.
Tangential acceleration. So this is what we used to call as net acceleration. So net acceleration is equals to square root of centripetal acceleration, square of centripetal acceleration plus square of tangential acceleration. I hope you all understand. Anybody having any doubt? You know, Mr. Monish, clear? Mr. Rohit, Manya and Samya, anything doubt? Please let me know. Understand, Princey? Murali?
Yes, sir.
Yeah. So this is actually, so see, I'm trying to explain more simplest way. So please all of you understand. So this tangential acceleration, centripetal acceleration also we can call it as what? Radial acceleration, or we can say normal acceleration, A normal. So R and A net. This all are, you can notice it. What they are? Linear acceleration or angular acceleration? Everybody?
Linear.
They all three are linear acceleration. So linear acceleration means, I think you might be find the formulas, everything. So I have been found centripetal acceleration formula v square by r, tangential acceleration formula, derivation of mod of vt divided by dt. That is what? Magnitude of velocity divided by dt. And then next one, centripetal acceleration over the net acceleration. What is the net acceleration formula? Root over AC square plus root over AT AC, centripetal acceleration square plus, next one is what, guys? Everybody?
Root AT square.
Yeah, tangential acceleration. Do you all clear, everybody?
Yes.
Understand, Amma?
Yes.
Yeah, now that is what. Now anything doubt you can ask me. Now we are going to study. So linear acceleration is over. So what is the opposite to linear acceleration? Next one, Mr. Narayan. Are you clear, Narayan? Pradeep? Pradosh? Anything doubt, please let me know. Understand, Amma?
Yes, sir.
That is what. So next we are going to study what, everybody? We are going to study what? Angular acceleration. Okay. So what is angular acceleration? What is the symbol of angular acceleration? Everyone? Yes, please. Alpha. Angular acceleration symbol is alpha. So now what do you mean by acceleration formula? Anybody can tell me? In 9th class we used to study. What is acceleration formula? Rate of change of what?
Change of velocity.
Rate of change of velocity.
Velocity.
Same way. Instead of acceleration, we are having angular acceleration, brothers. So that what will happen? Alpha is equals to rate of change of velocity
Rate
of,
of
yes, please speak. Rate of change in which velocity? Normal linear velocity or angular velocity?
angular velocity.
Angular
velocity.
in angular velocity. So that is only called as angular acceleration. So can I say angular acceleration is equals to change in angular velocity? What is the angular velocity formula? Anybody? Omega. So omega by t. So alpha is equals to omega by t, but rate of change means what should come? Change. Delta divided by delta t. So this is what is the angular acceleration. But again, two cases. Either it is made for average or instant. So average or instant. So if it is instantaneous, so what is that? Everybody. Instantaneous
omega by dt.
angular velocity, angular acceleration. So what will happen, everyone? D omega divided by dt. If it is average angular acceleration, so what will happen, everyone? Delta omega divided by. I hope everybody able to understand. Anything doubt, please let me know. Are you clear, all of you guys? Yes, please.
Yes, sir.
Of course, we'll prove it also. Proof also will do it. So anything doubt, you can ask me. So this is what angular acceleration. Now, let us find the relationship between angular acceleration and linear acceleration. So we all people knows that already. Let us revise again from the first class. So first, let us go with the units. So units of angular acceleration. Anybody can tell me what is the units of angular acceleration? First, omega. So what is the omega units, everybody? Radians per second. Am I right or wrong? So now radians per second. So that what is the acceleration? Everybody.
Radian per second
Square. Because normal acceleration, what is the units, guys? Meter per.
Second.
Now, that's all it is. Now, so it is vector quantity or scalar quantity? Acceleration is a vector. So angular acceleration is also a vector quantity. Manya and Samya, understand, Amma? Sai Karthik, Princy, any doubt, ask Mr. Murali. Are you able to understand? Mr. Monish, I want response, Monish, otherwise don't join. I'm very particular, Monish, because I want progress. Please remember. Whomever it is, no kind of tolerance. Can you able to understand or not? At least if not understand, again I'm ready to repeat, but I want things. Okay. Now we have studied already linear displacement S, angular displacement theta. So what is the relationship between them? S is equals to what, everybody? Speak loudly. S is equals to R theta. Linear velocity V, angular velocity omega. So what is the relation? Linear velocity
R omega.
Everybody.
R omega.
Same way. Now tangential acceleration or centripetal acceleration. This is what? Angular acceleration. So can you tell me what is the relation between that angular acceleration and acceleration? Anybody? So remember, centripetal acceleration also we can call it as normal acceleration, or we can also call it as what? Radial acceleration. So all of you remember, this is we cannot be. So always we can make the relationship between tangential acceleration and angular acceleration. So similar way, can you tell me what is the answer? Tangential acceleration is equals to, please speak loudly, which is equals to R
alpha.
R into angular acceleration. So that is what the relation. I hope you all understand, everybody. Yes?
Yes, sir. Yes, sir.
Any doubt you can ask. Clear, Amma?
Yes, sir.
Yeah. So this is what is about angular acceleration. Now, all of you keep it in mind. We have changed the velocity in two ways. Anybody can tell me how many ways we have changed the velocity? Everybody. Two ways. One is by direction. Another one is what?
Two.
One is by direction. Another one is
Magnitude.
what? For those
Magnitude.
let us velocity magnitude remains constant. Means, can you tell me? Magnitude remains constant means in the sense of, all of you respond, it is a tangential acceleration or centripetal acceleration. Everybody. Velocity remains constant. Magnitude is remains
Centripetal acceleration.
means velocity changes only by what? Only by direction. Keep in mind, whenever magnitude is remains constant, keep it in mind directly I'm saying, No change in magnitude is 0. So the tangential acceleration is what? Everybody, please
Zero.
respond. No change in understanding magnitude of velocity. So no change in magnitude of velocity. So change in magnitude of velocity remains constant, 0. So that what is the tangential acceleration? Speak loudly, everybody. 0.
Zero.
So keep in mind the most important, when the velocity magnitude of the bodies remains constant, means in a circular track everywhere VT remains what? Everybody, VT remains what?
Zero.
Constant.
Zero.
Understand? Those remains constant of this. Where velocity magnitude is not
Yes,
changing.
sir. Yes, sir.
Understanding? Magnitude is not
Actual
changing, but direction is changing. Magnitude of VT is what? Magnitude of VT remains constant. Do you understand? So tangential acceleration become what? Everybody. Tangential acceleration become what? 0. Understanding? So whenever velocity, that magnitude of the bodies remains constant, keep it in mind, the body will possess only one acceleration. What acceleration, everybody?
Centripetal acceleration.
Centripetal acceleration, whose formula is, what is the centripetal acceleration formula? V square by R. And at every point, it will act towards to the, at every point it will act towards to the what? Everybody, it will act towards to the center. So whenever the magnitude of velocities remains constant, so the tangential acceleration become what, guys? Everybody, tangential acceleration become 0. So now all of you remember, so we all knows that V is equals to R omega. We have derived the formula. Am I right or wrong? Check it, everybody.
Yes,
V
sir.
is equals to R omega.
Yes, sir.
So in a circular track, all of you remember, magnitude is remains constant. So V is remains constant. Who is remains constant? V means who is remains constant? Magnitude. Remains constant, and radius remains constant or changes at every point. Radius is remains constant or changes, everybody. Remains constant. So R is also constant. Then only who will varies? Already we have solved similar sums. So check it, everybody. So now R is constant and V is remains constant. So if you imagine, for example, so there is a object which is attached to the pivot point. All of you check it. So imagine this is the axis of rotation. What is this, Rudreswa? Axis of rotation. So yesterday I taught you how to find the direction of angular velocity. So imagine this is the particle now. So now imagine the particle is P particle and having a radius of R. This is the particle P having a radius of R. Now you tell me, when the bodies keep on revolving in this, so can you tell me what is the V, omega, that omega is remains constant or remains varies? Because V is remains constant. So omega also remains what? Angular momentum also. Everybody. So sorry, angular velocity also. Angular velocity also remains constant. Please respond. When V is remains constant and R is constant, angular velocity also remains constant. If angular velocity is not changing, so some other thing also will 0. Anybody can tell me? Just now we have studied that. AT is equals to R omega.
Tangential acceleration.
Yes. So tangential acceleration also. If omega is 0, because we all knows that alpha, what is the alpha formula? Just now we have done that. Alpha is equals to angular acceleration formula, guys. Please respond. What is the angular acceleration formula we have done? Delta omega divided by delta T. So change in omega is equals to 0. Change in omega is remains constant. So that angular acceleration also become what? Everybody, please respond. All of you, 0. Understanding, Amma? Everybody? So if tangential acceleration is 0, then automatically what will happen, everybody? Angular acceleration also will become what? Speak. 0. So very, very important point. Please note it. If tangential acceleration is 0, then angular acceleration of a body is also 0. That is what you have to remember. Because by which rule we will find the direction of angular velocity? Anybody? Yesterday I have taught you. What way we can? Everybody?
Right hand thumb rule.
By using right hand thumb rule. So imagine your 4 fingers are moving in this direction. Put it to my system. My screen is visible to you. You put your 4 fingers to your screen. So check it now. If the body, your 4 fingers are moving from this point to this point. Now, what is the direction of angular velocity? It is away from
outwards.
outwards. It is what, everybody? All of you? Please
Okay.
respond outwards. That is what you have to remember. So let us prove that even. We have written that angular acceleration, tangential acceleration is equals to R into angular acceleration. Am I right? Everybody? Pradosh, can you hear me? So let us prove that also. So we all people knows that, prove. So we all knows that tangential acceleration is equals to, what is the formula? Anybody? Tangential acceleration equals to derivation of magnitude of velocity divided by dt. Am I right or wrong? Speak, you people should speak. Now, tangential acceleration is equals to d into velocity means we all knows that. Just now here I have written. What is the velocity formula? Velocity is equals to r omega. Am I right or wrong, guys? Yes, please.
Yes, sir.
Yes, sir.
Yes. So you can replace it. So r omega divided by dt. Now, we all knows that radius is always remains what? Speak loudly.
Constant.
Radius is always remains
Constant.
constant. So d omega divided by dt. So just observe very carefully. D omega divided by dt, which is equals to something. What is that? Which is equals to all of you. Yes.
Instantaneous
Instantaneous
angular
angular acceleration. So can I say tangential acceleration is equals to, in place of d omega divided by dt, which is equals to angular acceleration. That is how the formula will obtain. Are you clear, everybody? Yes. So when a body is in circular track, tangential acceleration may become zero, but always some acceleration is existed. What is that acceleration which is always existed? Everybody.
Centripetal.
Yes.
centripetal
Centripetal
acceleration.
acceleration. So keep in mind, centripetal acceleration must be present in rotational or circular motion. Please note that point. Centripetal acceleration must be present in rotational or circular motion. I hope you all understand. Anybody having any doubt, please let me know. Clear, everybody? Girls, boys, all of you? Please respond.
Yes, sir.
Yeah. So very, very important. Mr. Sai Garde, can you able to understand, Mr. Sai Garde? Mani and Samya? Yeah. So that is what. So we have been proved that tangential acceleration equals to R into angular acceleration. So R omega. That's all it is. So when tangential acceleration becomes zero, so automatically angular acceleration also become what? Everybody. Angular acceleration also become zero. That is what you have to remember. Now, let us come to the tangential acceleration. As I said, tangential acceleration may be same direction of tangential velocity or maybe opposite direction of tangential. Everybody, tangential, respond. Tangential velocity. So now, let us take a circular path. Just I'm imagining path is difficult to draw. So that's what I'm taking. So I'm taking a, let's say, so imagine there is an object which has been attached to the pivot point. Which has been attached to the what point? Everybody? Pivot point. Okay. So I'm considering not here the particle. So this is the particle of my body. Is it okay? Pradosh, Laksha? So this is what is my particle. So which has been attached to the pivot point. Pradosh, can you able to hear me, Narayan?
Sir.
So pivot point. Now, what is the tangential velocity at this particular point, everybody? If I draw a tangent, that is what is the what? Tangential velocity. Understanding? So now omega, this body is revolving. So angular velocity is omega. Now all of you remember, what is the direction of tangential acceleration? Either parallel or anti-parallel. Keep it in mind. If we all people knows that, so tangential acceleration is equals to r into alpha. So keep it in mind, alpha increases. That is what? Alpha increases means what? Speed up. If alpha will speed up, angular acceleration will speed up. Angular acceleration will speed up. How angular acceleration will speed up? Anybody can tell me? How the angular acceleration will speed up? Means
Angular velocity.
angular velocity will changes. That is what magnitude of velocity will increases. Keep it in mind. Angular velocity will increases so that angular acceleration also will speed up by the time. Keep it in mind. So who is supporting here? Alpha. Alpha supports whom? Everybody. Alpha supports by angular velocity. So then the tangential acceleration, all of you remember, which will act in the same direction. So increasing. So if it is not, then tangential acceleration will act in the what direction? Everybody. Yes, please. downward direction. Understanding? Now here you have to be remember very carefully. All of you remember, if alpha is always acting here also. For example, alpha speed slow down, alpha speeds down, speed decreases. Here speed up and here speed down. Then you can remember alpha opposes omega. Alpha opposes omega. If alpha speed up, alpha what is happening? Alpha supports omega. If alpha speed down, what will happen to Rudreswar? Alpha opposes omega. Clear everybody? If alpha speed down, alpha will oppose the omega. If alpha will speed up, alpha will support the omega, angular velocity. Do you understand everyone? Clear everybody? Please respond. So, if both are, see, both are same direction, negative or positive or kadayadu, both are minus or both are positive. So that what will happen? Speed up or speed up or speed down? Everybody, speed up. Same sign. So that speed up. Opposite sign. This is already we studied previous chapter. Opposite sign means what will happen? 2 chapters before. Opposite side means it is speed down. Same sign means it is a what? Everybody. Same sign means it is a what? Speed up. Keep it in mind. So now I want to find the direction of angular velocity here. Can anybody tell me? Everybody. Angular velocity direction here along the axis. Imagine this is the axis of rotation. So yesterday also I told you angular